Let us look into the Kubernetes architecture. In Kubernetes, the whole Kubernetes is divided into two parts. One is the control plane, the other one is the data plane. The node having the control plane is called master node, and the nodes having the data plane is called worker node. Control plane contains a bunch of components that controls the state of the cluster. Control plane responds to different cluster events and takes necessary actions. These events could be a node join, that means a worker node is added, or a node is removed, or a instruction came to create a few ports. Anything like that is a event, and control plane responds to this event and take necessary actions. The worker node holds containerized application workload. The nodes have application ports as well as Kubernetes specific applications for interacting with control plane. Let us look into each of the components now. Let us look into what is a pod. Pods are the smallest deployable unit of computing that can be created and managed in Kubernetes. A pod can have one or many containers in it. So why should we bundle all these containers together in a pod? Consider a scenario that we have two applications. The output of one of the application will be processed by the next application. In this scenario, it will be better if these applications coexist. That means if it can share the same network, storage, or configurations, that will be better and it will be faster. So that is what we achieve through pods. In pods, we'll put both these applications or containers in the same pod. And whenever more pods are added, both the applications are replicated there. So the output of one of the application will be utilized by the second application which exists along with this application. So network latency will be less and applications will be faster. Now let us look into each of the components in control plane. First one is the API server. API server is the front-facing application of the Kubernetes cluster. Any external application can interact with the Kubernetes to create, update, or delete any of the configuration to API server. Kube API server is the one point where we can interact with the control plane. So Kube API server exposes so many APIs for different purposes, like for creating some of the resources, deleting some of the resources, getting the details of the resources, all those things. API server creates API objects for each of these resources like deployment, ports, nodes, service accounts, etc. So in API server, whenever we say that, okay, we need a deployment, then API server will go and create a deployment object. Then when a pod is created, a pod object is created. It doesn't mean that it is actually deploying the application. Its equivalent application will be deployed in the worker node by the kubelet. Kube Controller Manager is a service that has collection of controllers for different resources. Kube Controller continuously tries to bring the current state of the resource to its desired state. So what is the current state and desired state? If we are pushing a deployment instruction to the control plane, in that we might be saying that we need 3 ports of the specific image. So desired state is creating 3 ports. Now current state is just an instruction saying that we need 3 ports. So it's the responsibility of controller manager to bring that current state to the desired state. That means create 3 ports and make the current state to be the desired state. There are a bunch of controllers. For every resource, there's a controller. There's a deployment controller, node controller, job controller, etc. One of the next component is the kube scheduler. Kube scheduler watches for the ports which are not assigned to nodes and finds the best node for the ports to run on. So here, when a deployment instruction comes to the Kube API server, Kube API server will create a deployment object. Then the deployment controller will come into picture. Deployment controller will instruct API server to create 3 ports. These pods are not assigned to any worker yet. So it is the responsibility of the queue scheduler to find a specific node for that pod. For that, kube scheduler will check all the nodes and see which is the feasible node. Feasible node means the node that satisfies the requirement of a pod. Pods might have some specific requirements, like this much memory should be there, this much CPU should be there. Kube scheduler will check all the nodes and find the nodes which satisfy the requirement. The HCD server is a key value store which stores all the configurations that is pushed to the API server. That means all the manifest file details, everything, all the objects created, its different versions, everything is stored in the HCD server. Cloud Controller Manager links Kubernetes cluster with cloud provider APIs. Suppose our Kubernetes cluster is managed by a cloud provider, then it's the responsibility of Cloud Controller Manager to interact with the cloud provider's APIs. Kubelet is the primary node agent that runs on each node. Kubelet manages the actual state of the pods in the node as per the instruction from the control plane. We have seen that the Kube API server manages pod objects, node objects, etc. And the Kube scheduler will assign pod to a node. But still, the application is not deployed. So all these are happening in the master node. So from the worker node, it's the responsibility of kubelet to replicate all those instructions into the worker node and deploy all those applications. So kubelet will monitor the changes in the API server. Whenever it sees that a pod is added or removed for its specific node, the same thing will be replicated in the worker node. There, kubelet will deploy any application or remove any application. All those will be done by kubelet. Kubeproxy is a network proxy that runs on each node in the cluster. Kubeproxy maintains network rules on nodes. These network rules allow network communication to ports from network sessions inside or outside the cluster. So it's the responsibility of kubeproxy to add the network rules into the specific node. If you are using IP table, adding the routing rules in the IP table is the responsibility of kubeproxy for each of the ports and the services for that Kubernetes cluster. This is the overall architecture of the Kubernetes.